and then integral 0 to t f of s omega dws should be limit norm of pi tends to 0 s pi f s star omega for all omega in the sample space omega. Now it turns out that the above limit is strongly dependent on the choice of the sequence S star of the intermediate points which we choose. Now to see this, let f s omega is ws omega and take sj star is sj, the left endpoints of the intervals, subintervals. Okay, so what will be then? Then s pi f s star will be sum over j from 0 to n minus 1 w sj into w s j plus 1 minus w sj, right? Where w j is equal to w sj. Taking sj, and now let's denote this by phi pi, okay, and taking sj is equal to the right endpoint of the subinterval sj stars, we find and denote that sum by phi pi as S by F star is equal to sum over n minus 1 j from 0 to W S j plus 1 W Sj plus 1 minus W Sj, right? Now following the above approach, for all omega in omega, we should have integration 0 to t f of s omega d ws is equal to limit norm of pi tends to 0 phi pi omega should be equal to limit norm of pi tends to 0 psi pi omega, right? So the integral to be defined, we need all this to limit should be equal to integral in the sense of Riemann. So this phi pi and psi pi are nothing but they have considered the sum. Taking this Sj is the left endpoint of the subintervals, and for the second case right endpoint of the subinterval. So this should be equal, but now we'll see some problem. So in particular it should, so in particular phi pi minus psi pi must tends to 0 as the number of partition, this n tends to infinity. This means more finer and finer, and this means expectation of phi pi minus psi pi also tends to 0 as n tends to infinity. However, expectation of phi pi minus psi pi is equal to expectation of, if you calculate n minus 1 j from 1 minus 1 W S j plus 1 minus W S j square, which is equal to summation n minus 1 from j from 1 to n minus 1 Sj plus 1 minus Sj. This should be equal to t for all n greater or equal to 1, which is a contradiction.